Okay, so here you can see our top module for the project called New Clock Controller. It's a revised version of an old one, hence the new. You can see that it's broken into several smaller modules, and this made it much more manageable and easier to test. Just a couple snippets that we'll go over. First is, this is the module for essentially looping the time of the clock around so that, you know, once, say, the seconds get to 60, we don't actually want to display the number 60. We want to loop back to 0 like a normal clock would. And we do this by having, instead of using a single register for the time, we use multiple registers to have both the current time and also the next time. And you can see here that we do the looping essentially in the form of nested if statements. Since the top if statement evaluates whether the next seconds is going to be 60, since we wouldn't want the current seconds to actually get to 60, you can see here that it sort of avoids that by only setting the current seconds to the next seconds when the next seconds is less than 60. And then it will only increment the next minutes and the next hours to their current setting. Due to the fact that this is a nested if statements, it'll only happen when seconds hit 60 that these things will happen. Well, I suppose they're not nested if statements, more like nested else statements, but the effect is the same. It's just, this works as a very elegant way to loop all of those numbers around to their proper values.
Right, so in addition to getting time, a very interesting way that we've kind of formulated this clock was actually through how we set the times during the various phases where the alarm was being changed or the clock itself was being changed. So if you look over at the clock controller, we've created this little section that creates a variable called count. And count is only true when we're currently not setting the time, which ultimately lets the clock to count and keep incrementing its digits. Now, once that time, which is a certain switch, is on, the clock controller will stop. And this will also allow us to set at the intermediate values for the brand new clock. So this allows us to essentially change the values without messing with the current time, as current time has stopped. So this is a very elegant way of just allowing the clock to update itself without actually messing with the current time in any way, shape, or form while the user is inputting data.
So this is our design. You can see it's running in front of me right now. Let me just go over all the buttons. So we're using the reset button right here to set the clock back to 0 whenever we want. So you can see if I press it, it goes back to 0. Going through the other parts of it, an LED over here on the right will indicate AM or PM. An LED in the middle is going to indicate whether the alarm is on. As for these switches, the leftmost switch sets whether the alarm is on or off. The second switch sets the time format. So a 0 represents 24-hour time and a 1 represents 12-hour time. We'll go over that after. These switches here are for setting the time and the alarms. So this switch number 10, when it's set to 1, we're in a state where we are setting the time. These three switches here set respectively the hour, the minute, and the second. We can set the hour by turning the hour switch on. So let's say we want to set it to like 4 o'clock, which is 16. We would set the 16 high, right? Then we'd turn that down. We'd flip the minutes up to set the minutes. Let's say we want it to be 30. So we'd set, if I can count, 16 plus 8 is 24 plus 6, yeah, 30. And then seconds, let's just say we wanted seconds to be like 0. So that we're at 4:30 p.m., right? So that's all set. we would then turn the switch down and then turn off the set time switch. And so now we're counting again. And you can see if I change the time format, we switch to 8:30 and seconds, since that's the 12-hour version of 16:30 in seconds. And you can see here the PM light is on, indicating that we're in PM. So let's try just experimenting with the alarm. Like I said, this leftmost switch controls the alarm. We set the alarm in the exact same manner as setting the time using switch number 9. So let's set switch 9 high. We're going to set the hours high. So what's the time right now? Let's set it for 16:30. I'll just do it as I go. So we'll set the hours. Let's set it to 16 again. I'll set 16. Let's set the minutes to, let's set it to 34. 32 plus 2. No, that's not 32, that's 16. 32 plus 2. And then let's set the seconds to be 0. So that at 34, the alarm should go off. I'll set the alarm high. And then let's just wait until 16:34. And you can see the alarm LED blinks for a moment, indicating that the alarm went off. And yep, that's it.
So about just to discuss some of the successes and failures of this project. One of the things that didn't work out so well is the way that we first wrote this Verilog. I'll actually even show it here, is that we had hard coded the state encodings. So you can see here, we actually, in the old version of this, we actually had a module that determined the state we're in, so that essentially it allowed the user to hit a button to cycle through the different settings for the clock, like set the time format. But we thought the way this worked was rather elegant. The issue is that no matter what we tried, we kept getting a combinatorial logic loop when we ran synthesis and implementation, and trying lots of debugging with it just ultimately didn't fix that issue, and we weren't really sure how to fix it. So we had to discard. We determined that this was what was causing it. We're still not sure why. So we had to discard that idea and instead basically just have the states being like an implicit part of the project. So maybe looking into that further next time would be helpful in doing projects in the future.
Another little setback that we had is the fact that within our clock, the actual seconds counts a little bit too fast, and it doesn't exactly match up with the 1 Hertz clock that we were trying to get it to count with. We're not exactly sure why it counts faster, and it counts multiple times in a second. And that is something we will have to look in a little bit further in the future. But we are very proud of the fact that we have a working clock, albeit the time is a little off.